Hey everyone, welcome back to the channel. In today's video, we are diving into something exciting and beginner friendly. That is LangGraph's core components by building the simplest graph possible. Before we get into the technical parts, let's take a step back and look at the bigger picture. What exactly are we building and how does it flow? We will start with a simple sentence. Hi, this is Venki. This will be passed into the graph as the starting state. The graph begins at the first node. That node takes the input and adds the word I am. So the sentence becomes Hi, this is Venki, I am. Next, the graph reaches a decision point. A conditional edge randomly decides the mood, either happy or sad. Based on that, the graph moves to the one of the two nodes, one that adds happy and one that adds sad. So, the final output will be either Hi, this is Venki, I am happy, or Hi, this is Venki, I am sad. That's it. A simple yet powerful example that shows how data flows. Decisions happen and results are generated in LangGraph. Let's now break this down into four simple components. That is state, nodes, edges, and graph execution. We will explain each one and then immediately walk through the code for it. Let's start with the state. The state is like a shared memory. It carries data as it flows through the graph. Every node in the graph reads from and writes back to this state. In our example, we define a state using Python's typed dict, which just has one field called graph state. Let me show you how we define that in code. Next are the nodes. Nodes are the building blocks of your graph. Each node is a simple Python function. It receives the current state, performs an operation, and returns an updated version of the state. In our graph, we define three nodes. The first node adds I am, the second node adds happy, and the third node adds sad. Each of these simply appends to the graph state string. Let me show you how those nodes functions look in code. Now, let's talk about edges. Edges define how nodes connect and in what order they execute. A normal edge connects one node directly to the next, but a conditional edge adds decision logic. It chooses the next node based on the current state. In our case, we are using a simple random condition to decide if the graph should go to the happy or sad node. Let's take a look at how that conditional edge function is written in code. Now that we have our state, nodes, and edge logic, it's time to assemble the graph. This is where the graph construction step comes in. We use the state graph class to register our nodes, wire them together with edges, and define where the graph starts and ends. Once everything is added, we will compile the graph and it's ready to run. Let me show you how we put all these parts together in the actual graph code. Finally, let's see how to run the graph. We do that by calling .invoke method with our starting state. The graph starts at node 1, moves forward based on the edge logic, and ends either the happy or sad node. When execution finishes, it returns the updated state. Let me show you how we invoke the graph and what's the output look like. In the next video, we will build a chat-powered chain that uses tools, chat models, and more advanced graph logic, all powered by LangGraph. So make sure to subscribe, hit like, and turn on notification. You don't want to miss it. Thank you for watching. Keep building smart with LangGraph.